Okay, so in 10.2 we did exponent product rules. So now in 10.3 we're going to do exponent quotient rules. So our objective is I can use exponent quotient rules to solve problems. So the only difference between yesterday's learning goal and today's learning goal is we're doing quotients instead of products. Okay, so the first one we're going to talk about is one that you actually learned in Big Ideas. The other one is one that you didn't learn in Big Ideas, but it's very similar to one that you did learn in Big Ideas with products, so we'll just be applying it to quotients. Okay, so if you remember, when you have a quotient of powers, and you're dividing, so that's where quotient comes from. Okay, same base, that's really important. Remember, they have to have the same base. Okay, you subtract their exponents and keep the base the same. Okay, now we're going to get to some that have some other numbers in there, and I'll talk to you about how to simplify those. But with the exponents, you subtract. Okay, now remember a rule of thumb. Okay, only numbers, and it's written down here as well. Okay, only numbers means write as a power. Okay, otherwise you can simplify, actually like multiply the number out. Okay, so here, okay, I have the same base, 5 is my base, so I'm going to subtract 6 and 2. So I have 5 to the 6 minus 2, well 6 minus 2 is 4, so I can simplify that to be 5 over 4. Okay. For the second example, if you notice on the top here, we have something that's not quite simplified all the way. Okay, so I know that I can add those, okay, based on yesterday's notes. Okay, so I'm going to have 5 plus 5, which is 10, so I have 10 to the 10th over 10 to the 4th. Okay, well now I know I need to subtract those, which would be 10 to the 10 minus 4. Well, 10 minus 4 is 6. Okay, so that's pretty easy. Okay, I'm going to go ahead and switch over to this, to my foldable. Okay, so this is quotient of powers, so this is the second one. Okay, so that tells me when I have a to the m over a to the n, that simplifies to a to the m minus n, like that. Okay, so here, for this one, I would do 6 to the 4 minus 3, which is just 6 to the 1. Well, I don't need to write that 1. That's my implied 1, like 1x. Right? I don't have to write the 1 on 1x. Okay, well, you don't have to write the 1 when it's to the first power. Okay, so now back over to this one. Now remember, if it starts in parentheses, you need to leave it in parentheses. Now I will show you an example down here when you'll take the negative off, but for the purposes of what we're doing, you're going to leave it on. So I have negative 6 to the 8 minus 5. Well, 8 minus 5 is just 3. So I have negative 6 to the 3rd. Okay. Now this one looks a little bit different because you have this number here. Okay, this negative 44 over 11. Well, we can simplify that. Okay, so I'm basically separating this into two different fractions. So I have negative 44 over 11 times z to the 11th over z to the 6th. Well, I know that negative 44 divided by 11 is negative 4. And then z to the 11th over z to the 6th, I know I subtract those powers. So when I simplify that, I get z to the 5th. So my simplified answer would be negative 4z to the 5th. Okay? Okay, and then our last example on this one, I have this one, and I have this one. So I have 5 tenths, and then b to the 9th over b cubed, and c to the 7th over c to the 4th. Okay, so I'm going to simplify these one at a time. Now, one of the biggest mistakes I see a lot of you making is we want to say that 5 over 10 is the same as 2. Well, it's not. 5 out of 10 isn't 2. Okay, 5 out of 10 is 1/2. Okay. Okay, so then I'm going to simplify b to the 9th over b cubed. So that's b to the 9th minus 3, which would be b to the 6th. Okay, and then I have c to the 7th minus 4, because I'm subtracting 7 and 4, which gives me c cubed. I'm going to rewrite that, and I'm going to rewrite it without this 1, because again, that's my implied 1 that I don't need. Okay, you do need to leave the 2 on the bottom. So it's b to the 6th, c to the 3rd over 2. You can leave the 1 if you want to. It's not wrong. It's just not necessary. Okay? So now we're going to move on to power of a quotient, which is not something we learned in Big Ideas, but all you have to do is you do the same thing if you have a power of a product. So same as power of a product, which if we look back at power of a product, okay, we just distributed that exponent to both parts of that. Okay, so on this one, we're going to apply or distribute the exponent to each piece of the division problem. Okay, simplify any numbers and write as a fraction, or you can call it a fraction or write it as a quotient. Now, remember, we don't use this anymore. We don't use that. That's a big no-no. Okay, we write it as a fraction. Okay, so over here for power of a quotient, if I have a divided by b to the m, that's the same as a to the m over b to the m. Now, a lot of people are going, well, if you subtract m and m, then you get 0. Okay, well, remember, you can only subtract them if they have the same base. Okay, so like on this one, both were a, so that's why I could subtract them. I can't subtract them here, okay, because this is a to the m and this is b to the m, so not the same base. Not same base. Okay, whereas over here, okay, if you look at this, if I had a over a to the m, well, what's a over a? That's just 1. Okay, so if I had a over a on the inside of a parenthesis and then an exponent on the outside, that would just simplify to be 1. Okay, so these are two very different things. Okay, so when I do this, okay, I'm going to apply this to both. So I'm drawing my arrows, just distributing just like normal. Okay, so that's 4 cubed over 2 cubed. Okay, now obviously this is 2 on the inside, but they're just showing you with an easy example. Okay, so we will finish these ones next time in 10.4. Okay, so just so you remember, this is from 10.2, this is from 10.2, this is from 10.2, this one's from 10.3, and this is just from Miss Hart. Okay, but we related it to something we learned in 10.2. Okay, so I'm going to use that same rule here. Okay, so I'm applying that 5 to p and q. So that just gives me p to the 5th over q to the 5th. Pretty easy for that one. Okay, now this is one where you actually are going to simplify the number. Now, it's really important that only one part of fraction gets the negative. Okay, that's important because if I have a negative divided by a negative, well, that's a positive. Okay, so I know both of them can't be negative. You can pick which one you want to be negative. It will work itself out. I usually go with the top one just for consistency. So I'm going to rewrite this as negative 4 over x to the 4th. And then I'm going to apply that. Now, because this is in parentheses, it needs to stay in parentheses. So that gives me negative 4 to the 4th over x to the 4th. Okay, and now because I have a variable, I'm going to go ahead and evaluate my negative 4 to the 4th. So I'm putting negative 4 in parentheses, okay, and then I'm raising it to the 4th power, okay, which gives me 256. So I'm simplifying this to 256 over x to the 4th, okay? So that's my final answer on that one. Okay, now we're getting real crazy, okay? So now I'm going to apply this squared to every piece. That includes the 3 and the y cubed, okay? Both the 3 and the y cubed to get the squared. So I have x squared, okay? 3 squared, and y cubed squared. So we're going to have to use some of our other properties that we learned in a previous day. Okay, so remember when I have a power to a power, let's look back, power to a power, looks like I multiply those exponents. Okay, so that's what I'm going to do. So 2 times 2 is 4. Okay, I'm going to go ahead and simplify 3 squared. 3 squared is, remember, 3 times 3, okay, which gives me 9. And again, I'm only simplifying because I have variables, okay? And then multiply 3 times 2, and I get 6, so y to the 6. So that's the final answer for that one. Okay, and then this last one, back to something simple. Okay, just distributing that 3, that cubed. So I have 3 cubed over 5 cubed, and because it's only numbers, I'm leaving it as a power. On your test, I will make sure to tell you, like, leave it as a power or don't leave it as a power. So if I say leave as a power, okay, that means don't evaluate. Don't evaluate numbers. Okay. Now, if I say simplify, okay, when I say simplify, that means evaluate numbers. So when I say numbers, what I mean is like this. Okay, because obviously you can't do x to the 4th because you don't know what x is. Okay, but I could figure out what 3 cubed is, but the whole point of this is for me to see that you understand that like instead of you typing in 3/5 to the 3rd, which you could easily do and the calculator would spit out a fraction, I want to see that you understand this property, which is why I have you leave it as that power instead of evaluating it. Okay? Okay, so you're going to go ahead and do these U tries. I'm going to go ahead and tell you how much each is worth. Okay, so this is going to be worth 1 point on your quick check. This is going to be worth 1 point. Those are 1 points just because they're harder. Okay, and then these are each going to be worth half a point. Okay, so these are, when you come in to do your quick check, that's how you're going to know if you really understood the material. Okay?